Hello, in this lecture we will find out the area of the green triangle. In the drawing we have square ABCD. We know that the length of one side of square ABCD equals to 4 units. Inside this square we have a circle. The radius of this circle is equal to 1 unit, and we want to find out the area of the green triangle, triangle EBC. Okay, so first of all I will present to you a new rule, rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. I will read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So, what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and we have a tangent to this circle, tangent AB, this tangent is tangent to the circle at this point. We will define this point as point M. Point M is the point of tangency of tangent AB with this circle. We will define the center of this circle as point O, and we have the radius R, that is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency. I write down that point M is the point of tangency of tangent AB with this circle. Okay, and we actually can see from the drawing that the radius of this circle OM is the radius of this circle. This radius is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency of tangent AB with this circle. Therefore, according to rule number 1, a tangent to a circle, that is to say AB, is perpendicular to the radius drawn to its point of tangency. So we have this radius that is drawn to the point of tangency. Therefore, according to rule number 1, this tangent AB, is perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay, so whenever we have a radius, like in this drawing, that is drawn to the point of tangency, then the tangent AB will be perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? So, we actually can implement rule number 1 in our drawing, because in our drawing we have this radius. We will define the radius of this circle as r, and we know that r is equal to 1 unit. We will define the point of tangency of tangent AD with this circle, this point, as point M. Point M is the point of tangency, this point, with this circle, and we have this radius that is drawn to the point of tangency. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we also know that all the angles inside the square are right angles, so this angle, angle DAB, is one of the 4 angles of square ABCD. Therefore, it equals to 90 degrees. So this angle equals to 90 degrees. And we have here AB or AE or AB is tangent to this circle at this point. We will define the point of tangency of tangent AB with this circle as point N. So this point is point N, point of tangency of tangent AB with this circle. And then we will define the center of this circle as point O. We will join points O and N together by a straight line. ON is the radius of this circle, that is to say it equals to 1 unit. Why ON is the radius of this circle? Because of the fact that line segment ON starts from point O, that is the center of this circle, and ends at point N, that is a point on the circle itself. Therefore, it is defined as the radius of this circle. And again, we have this radius, the radius ON, it is drawn to the point of tangency. That is to say, it is drawn to point N, that is the point of tangency. Therefore, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? So, actually, in quadrilateral MOAN, this small quadrilateral, we have 3 right angles. 1, 2, 3. And the sum of 3 right angles is 90 times 3 is 270 degrees. And if we define this angle, angle MON, as angle X, in total, we will get that the sum of those 3 right angles is 270 degrees. So we will focus on quadrilateral MOAN. In quadrilateral A and O, this quadrilateral, we have three right angles, and the sum of those three right angles is 270 degrees plus this angle that we define as angle X. So 270 degrees plus the size of angle X is the sum of the angles inside quadrilateral MO and O. MOAN. Okay? I will repeat again. 270 degrees plus angle X is the sum of the four angles inside quadrilateral MA and O. And we actually have rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. I will repeat again on rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, if we focus on quadrilateral MA and O, we know that the sum of the four angles of quadrilateral MA and O is 270 degrees plus X, and according to rule number 2, the sum of its four angles is equal to 360 degrees. Okay, this is true according to rule number 2. Okay, we will subtract 270 degrees from this equality, and we will get that angle X equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle X equals to 90 degrees. Okay, angle X equals to 90 degrees. So we can replace here angle X by 90 degrees. So as you can see, in quadrilateral MOAN, this quadrilateral, we have four right angles. All the angles inside quadrilateral ANOM are right angles. They are equal to 90 degrees. And we have rule number 3. According to rule number 3, any quadrilateral that has four right angles must be at least a rectangle if not a square. So I'll read rule number 3 again. According to rule number 3, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. And in our drawing, quadrilateral MOAN, this quadrilateral has 4 right angles, therefore we will relate to quadrilateral MOAN as a rectangle. Okay, I write it down. We will relate to quadrilateral MOAN, this quadrilateral as a rectangle. Okay, and we also have rule number 4, that states that the opposite sides of a rectangle are equal to each other. The opposite sides of a rectangle are equal to each other. So I read rule number 4 again. Rule number 4 states that the opposite sides of a rectangle are equal to each other. And actually, as I've already said, quadrilateral MOAN is a rectangle. This quadrilateral MOAN is a rectangle. And according to rule number 4, its opposite sides are equal to each other. That is to say, MO equals to AN. MO equals to AN according to rule number 4. Side MO equals to side AN in quadrilateral in rectangle MOAN. I will repeat again. In quadrilateral in a rectangle MOAN, in rectangle MOAN, in rectangle MOAN. MO equals to AN according to rule number 4. But we have already found out that it is actually given us in the question that MO is the radius of the circle and it equals to 1 unit. So we can write here that MO, according to what is given us in the question, MO equals to 1 unit. So from this equality we will get that AN also equals to 1 unit. Okay, AN equals to 1 unit, so we can write here that AN equals to 1 unit. Okay, AN equals to 1 unit according to what we found. Likewise, according to rule number 4, MA equals to ON. Side MA of the rectangle equals to ON according to rule number 4. But we have already found out also that ON equals to 1 unit. It is the radius of the circle. ON equals to 1 unit. Okay, ON equals to 1 unit. From this equality, we will get that MA also equals to 1 unit. Okay, we write it again. MA equals to ON and it equals to 1. And from this equality, we will get that MA also equal, or we will derive that MA also equal to 1 unit. MA equals to 1 unit. So we can write here that MA equals to 1 unit. So as you can see in the drawing, quadrilateral MOAN has 4 right angles and it has also 4 equal sides. All of its sides are equal to 1 unit. And we also have rule number 5. According to rule number 5, any quadrilateral that has 4 right angles and 4 equal sides is a square. So I will read rule number 5 again. Rule number 5 states that any quadrilateral that has 4 right angles and 4 equal sides is a rectangle. And quadrilateral MOAN has 4 right angles and 4 equal sides, therefore quadrilateral MOAN is a rectangle. So we can conclude from rule number 5 that quadrilateral MAON is a square. Okay. And we also have rule number 6. Rule number 6 states that the diagonals of a square bisect or cross the angles of the square into 45 degrees angles. So I will read rule number 6 again. According to rule number 6, the diagonals of a square bisect the angles of the square into 45 degrees angles. So according to rule number 6, the diagonal OA, this diagonal, the diagonal OA of square MOAN bisect this angle into 45 degrees angles. So this angle will be equal to 45 degrees, and this angle will be also equal to 45 degrees. This is according to rule number 6. Okay, because quadrilateral MOAN is a square, and AO is the diagonal of this square. Therefore, according to rule number 6, it bisects this angle into angles of 45 degrees. This angle will be equal to 45 degrees, and this angle will be also equal to 45 degrees according to rule number 6. Likewise, the square ABCD has diagonal AC, and according to rule number 6, the diagonal AC, this diagonal of the big square ABCD, bisects the same angle into 45 degrees angles. This angle equals to, so angle CAB equals to 45 degrees. Okay? So I can write down that according to rule number 6, angle OAB, this angle OAB, angle OAB equals to 45 degrees. Actually, we know that side AB is tangent to this circle at point N. Point N is the point of tangency of tangent AB with this circle. What does it mean? It means that point N is located on the tangent AB, because tangent AB is tangent to this circle at point N. That is to say, point N is on tangent AB. Therefore, it doesn't matter at all if I relate to angle AON or angle OAB. It is the same angle, because of the fact that point N is located on the tangent AB. It's exactly the same thing to say that angle OAB equals to 45 degrees or angle OAN equals to 45 degrees, because point N is located on tangent AB. Okay, so I wrote down that angle OAB equals to 45 degrees. Likewise, angle CAB also equals to 45 degrees according to rule number 6. Angle CAB also equals to 45 degrees. Okay, this is according to rule number 6. So those two angles are both equal to 45 degrees. So from the fact that angle OAB equals to angle CAB, so we know that angle OAB equals to angle CAB. Okay? Angle OAB equals to angle CAB. What does it mean? It means that the diagonal CA must pass through point O. I will write down the conclusion. We will derive from the fact that angle OAB equals to angle CAB that the diagonal CA of square ABCD passes through point O. The diagonal AC of square ABCD, the big square, passes through point O. Otherwise, if we assume that the diagonal AC passes from point O, then it is impossible that angle CAB will be equal to angle OAB, because they have equal side, the same side, they have common side. AB is a common side to those both angles. CAB has one side, angle CAB consists two sides, side CA and side AB. And angle OAB also consists of two sides, side OA and side AB. So those two angles have the same side, side AB. Side AB belongs to both angles. And they are equal in, the angles are equal to each other. They are both 45 degrees. And because of that fact, diagonal CA must pass through point O. Otherwise, angle CAB will not be equal to angle OAB. Okay, therefore we will conclude that the diagonal CA of square ABCD passes through point O. Okay. In the next step, we will define the touching point between tangent EC, CE, to this circle, or the point of tangency of tangent CE with this circle is point K. Point K is the touching point of tangent CE with this circle, and we will join together points O and K by a straight line. What is KO? KO is the radius of this circle. Why KO is the radius of this circle? Because of the fact that line segment KO or OK starts from the center of this circle and ends at point K, that is a point on the circle itself. Therefore, that is exactly the definition of a radius. Therefore, it is the radius of this circle that equal to 1 unit. So, this radius, OK, it is drawn to the point of tangency. That is to say, it is drawn to point K, that is the point of tangency of tangent EC with this circle. Therefore, according to rule number 1, the tangent EC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? In the next step, I will present to you a new rule, rule number 7. According to rule number 7, the length of the diagonal of a square is equal to square root of 2 multiplied by the length of the side of the square. So I will read rule number 7 again. According to rule number 7, the length of the diagonal of a square is equal to square root of 2 multiplied by the length of the side of the square. So what is the meaning of rule number 7? The meaning of rule number 7 is that if we have square ABCD So this is square ABCD. And if the length of one side of this square, suppose so that the length of side AB is equal to S units, so all the other sides will also equal to S units in their lengths. So if the length of a square is equal to S units, then the length of its diagonals, that is to say the length of diagonal BD, will be equal to square root of 2 times S units. Okay? So if the length of square ABCD equals to S units, then the length of its diagonals will be equal to square root of 2 times S units. Okay, that is the meaning of rule number 7. So we can implement rule number 7 in our drawing. We will find out the length of diagonal AO of the small square of square MOAN. If the side is equal to 1 unit, then the length will be equal to square root of 2 times 1, that is to say it will be equal to square root of 2 times 1 is square root of 2. So the length of the diagonal AO of square MOAN is equal to square root of 2 units according to rule number 7. Likewise, we will calculate the diagonal, the length of the diagonal of the big square, square ABCD. We know that the length of one side of square ABCD equals to 4 units. Therefore, the length so we already found out that according to rule number 7, the diagonal AO equals to square root of 2 units in its length, and likewise the diagonal AC will be equal to the length of the side of square ABCD, that is actually 4 units, times square root of 2. So AC equals to 4 times square root of 2 units. AC, the length of the diagonal of square ABCD, the big square ABCD, equals to 4 times square root of 2 units. The length of the side, that is 4 units, times square root of 2, according to rule number 7. So what is the length of CO? The length of CO, you can see from the drawing that CO equals to AC minus AO. Again, CO equals to AC minus AO. So I write it down. CO equals to the length of the diagonal ABCD, that is AC, the length of the diagonal ABCD is AC, minus the length of the diagonal of the small square AO. okay, minus AO. CO equals to AC minus AO, okay, CO equals to AC minus AO, but we have already found out that AC equals to 4 times square root of 2 units and AO equals to square root of 2 units. That is to say, CO equals to 4 times square root of 2 units minus square root of 2 units. So 4 times square root of 2 units minus square root of 2 units equals to 3 times square root of 2 units. So we found out that CO equals to 3 times square root of 2 units. So we can write here that CO, this line segment CO equals to 3 times square root of 2 units. Okay? And we also know that KO equals to 1 unit. It is the radius of this circle. So in the next step we will focus on the right triangle, triangle COK. So on the right triangle, triangle COK, according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars in any right triangle. If we focus on the right triangle, triangle COK, this triangle, this right triangle, triangle COK, the hypotenuse is CO. So the square of the hypotenuse is CO square. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OK square plus KC square. I will repeat again. In the right triangle, triangle COK, this right triangle, according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, we will get that the hypotenuse is CO. So the square of the hypotenuse is CO square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OK square plus CK square. Okay? But we have already found out that CO equals to 3 times square root of 2. CO equals to 3 times square root of 2 units, so CO square will be equal to 3 times square root of 2 units square. CO equals to 3 times square root of 2, so CO square will be equal to 3 times square root of 2 square. OK, KO or OK equals to 1 unit, so OK square is 1 square is 1, plus KC square. KC square is KC square, we will leave it as it is. So here we have 3 times square root of 2 square, it is actually equals to 3 square is 9, and square root of 2 square, it is 2. So in total we got 9 times 2 equals to 1 plus kc squared. Here we will subtract, first of all, we know that 9 times 2 is 18, so we write it down that 18 equals to 1 plus kc squared. So here we will subtract 1 from this equation, equation number 1. 18 minus 1 is 17. We will get that 17 equals to kc squared. Here we will take a root out of this equation, equation number 1, and we will get that kc equals to the square root of 17. We found out that kc, according to equation number 1, kc equals to the square root of 17 units. So we can write here that this side kc equals to square root of 17 units, so I write it here. It equals to the square root of 17 units. So in the next step, I will present to you the last new rule, rule number 8. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. I will read rule number 8 again. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 8? The meaning of rule number 8 is that if you have this circle and we have this point P is an external point, y point P is an external point because point P is not located inside this circle now, nor on this circle, but it is located outside this circle. Therefore, point P is defined as an external point of this circle. So if from point P we will draw two tangents to this circle, the first tangent, so point P is actually a common external point. Okay, because it is, because from this point we will draw those two tangents, therefore it is common to these two tangents. The two tangents that I will draw exit from point P, therefore it is a common external point. So from point P we will draw the first tangent, this tangent. We define the touching point of the point of tangency of the first tangent with this circle as point A. Point A is the point of tangency of tangent of this tangent of this first tangent with this circle, and then from point P we will draw the second tangent to this circle. And we will define the touching point between the second tangent and the circle as point P. Point B is the point of tangency of the second tangent with this circle. So the length of the first tangent is PA. The length of the second tangent is PB. And according to rule number 8, the lengths of two tangents from a common external point to a circle are equal. That is to say, PA equals to PB. So whenever you draw two tangents from a common external point, like in this drawing, from the point P to a tangent, then to a circle, then the lengths of those two tangents will be equal to each other. That is to say, PA equals to PB. So whenever you have an external point of a circle and you will draw from that external point two tangents to a circle, then the lengths of those two tangents will be equal to each other. In this drawing, PA equals to PB. And we can also implement rule number 8 in our drawing, because in our drawing we have this point E here. Point E is an external point to this circle, and from point E we have two tangents to this circle. The first tangent is this tangent, tangent EK, and the second tangent is tangent EN. Therefore, according to rule number 8, whenever you draw two tangents to a circle from a common external point, like in this drawing from point E we have two tangents to this circle, then the lengths of those two tangents will be equal to each other. That is to say, EK equals to EN according to rule number 8. Okay, so EK equals to EN according to rule number 8. Because the length of two tangents from a common external point to a circle are equal. We have external point E, then from the common external point E we have two tangents, tangent EA, EN and tangent EK, therefore the length of those two tangents will be equal to each other. That is to say, EK equals to EN according to rule number 8. And if we define the length of EN as x, then EK will be also equal to x because the length of those two tangents are equal to each other. So here we will get that En equals to AK equals to x according to our definition. So the length of those two tangents are equal to x according to our definition. In the next step, we will find out the length of EB. What is the length of line segment EB or side EB? The length of EB, you can see from the drawing that the length of EB is actually equals to AB minus AN minus NE equals to EB. AB minus AN minus EN equals to EB. Okay? Very simple. If you subtract from AB, AN, and EN, you will get EB. Very simple. Okay? So EB, from the drawing you can see that EB equals to AB, that is the side of the square ABCD, minus AN, this line segment, minus EN. Okay? EB equals to AB minus AN minus EN. So EB equals to AB equals to 4 units, AB equals to 4 units, all the sides of square ABCD are equal to 4 units, so AB equals to 4 units, minus AN. We have already found out that AN, it is the length of the side of the small square, it equals to 1 unit, minus EN. EN equals to x according to our definition. En equals to x. So in total we found out that EB equals to 4 minus 1 is 3 minus x. So EB equals to 3 minus x. EB equals to 3 minus x. So we can write here that EB equals to 3 minus x. So we will focus on the green triangle, that is a right triangle. Why the green triangle is a right triangle? Because this angle is angle B is 1 out of 4 angles of square ABCD. And we know that all the angles inside the square are right angles. That is to say, this angle CBA, is a right angle. That is to say, it equals to 90 degrees. And if angle B or CBA equals to 90 degrees, then the green triangle is a right angle. So we can implement the Pythagoras theorem in the right triangle, the right green triangle, triangle CBE. Okay, and according to the Pythagoras theorem, in the right green triangle, triangle CBE, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the green triangle is CE. Therefore, the square of the hypotenuse is CE squared. CE squared. And it equals to the sum of the squares. The hypotenuse is CE. Therefore, the square of the hypotenuse is CE squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to EB squared plus BC squared. And we know that all the sides of a square are equal to each other, so all sides of square ABCD, they are equal to 4 units, therefore BC, that is one of the sides of square ABCD, also equals to 4 units, so we can write here that BC equals to 4 units. So you can see in the green right triangle, the only missing variable is x. Okay, so we actually found out, according to the Pythagoras theorem, in the right green triangle, triangle CBE, CE squared equals to EB squared plus BC squared. We have already found out the length of CE. As you can see from the drawing, the length of CE, the length of the hypotenuse of the green triangle, CE or EC, equals to square root of 17 plus x. So EC equals to square root of 17 plus x. If c equals to square root of 17 plus x, then CE squared will be equal to square root of 17 plus x squared. So CE squared equals to square root of 17 plus x squared plus EB squared. EB equals to 3 minus x. EB equals to 3 minus x. If EB equals to 3 minus x, then EB squared will be equal to 3 minus x squared plus BC squared. So you can see here, BC equals to 4 units. If BC equals to 4 units, then BC squared will be equal to 4 squared. 4 squared is 16. In total, we got that CE squared is square root of 17 plus x squared. EB squared is 3 minus x squared. BC squared is 16. So here we will open the brackets on both sides of equation number 2, and we will get that square root of 17 plus x squared is 17 plus x squared plus 2 times square root of 17 times x, according to the algebraic identity that a plus b squared equals to a squared plus b squared plus 2 times ab. And it equals to 3 minus x squared. 3 minus x squared is 9 plus x squared minus 6x plus 16. Okay, so here we have here x squared in both sides of the equation number 2, so x squared will get cancelled. 9 plus 16 is 25, so I'll write it down. We will get that 17 plus 2 times square root of 17 times x equals to 9 plus 16 is 25 minus 6x. Here we will subtract 17 from this equation number 2, and we will get that 2 times square root of 17 times x equals to 25. Here 17 minus 17 is 0, is 25 minus 17 is 8, minus 6x. Here we will divide equation number 2 by 2, and we will get that square root of 17 x equals to 4 minus 3x. Here we will add 3x to this equation number 2. And we will get that square root of 17 x plus 3x equals to 4. So we got that square root of 17 times x plus 3x equals to 4. Here we'll take a common factor x out of these expressions, and we will get that x is a common factor. Inside the brackets, what is left from square root of 17x after we took a common factor x as a common factor, what is left, it is actually square root of 17, and what is left from 3x after we took x as a common factor, what is left, it is actually 3, and it equals to 4. So here we will divide this equation number 2 by square root of 17 plus 3, and we will get that x equals to 4 over square root of 17 plus 3. Here we will multiply this side of equation number 2 by square root of 17 minus 3, and then we will divide it by square root of 17 minus 3, and we will get that x equals to 4 times square root of 17 minus 3 over square root of 17 minus 3 divided by square root of 17 plus 3 . As you know, the identity, the algebraic identity, that a square, a plus b times a minus b equals to a square minus b square. Okay, we will use this algebraic identity in order to find out the value of this expression. A plus b times a minus b equals to a square minus b square. So we will get that according to this algebraic identity, x will be equal to 4 times square root of 17 minus 3 over square root of 17 is a, so a squared is 17, minus b squared is minus 9. So in total, we found out that x equals to 4 times square root of 17 minus 3 over 17 minus 9. 17 minus 9 is 8, so I will write it down. We will get that according to equation number 2, x equals to 4 times square root of 17 minus 3 and 17 minus 9 is 8. So x equals to 4 times square root of 17 minus 3 over 8. Here we will divide the numerator and the denominator by 4, and we will get that x equals to square root of 17 minus 3. 4 over 4 is 1 and 8 over 4 is 2. Okay, we found out the value of x. X equals to square root of 17 minus 3 over 2. And we want to find out the area of the green triangle. That is the right triangle. What is the area of any triangle? The area of any triangle equals to the base of the triangle times the height over 2. The formula for the area of any triangle is the base of the triangle times the height of the triangle over 2. So the area of triangle EBC, actually this is the sign of the area. It means the area of triangle EBC will be equal to the base of the triangle EBC, that is actually EB. The base is EB. Times the height. The height of triangle EBC is BC over 2. Okay, we found out that the area of the green right triangle, triangle EBC, equals to EB times BC over 2. This is according to equation number 2. So we will get that the area of the green right triangle, triangle EBC, equals to EB. EB is 3 minus x times BC. BC is equals to 4 units over 2. So we found out that the area of triangle EBC equals to 4 minus x. 3 minus x times 4 over 2. 4 over 2 is 2, so I write it down. We'll get that the area of triangle EBC, according to equation number 2, equals to 4 over 2 is 2, so it is 2 times 3 minus x. We have already found out the value of x, so we will place the value of x inside x in this equality. In equation number 2, we will place the value of x inside x in this equality, in this equation number 2, and we will get that the area of triangle EBC, according to equation number 2, equals to 2 times 3 minus x. So we will place the value of x inside this, inside x. X equals to square root of 17 minus 3 over 2 here we will multiply 3 by 2 and then we will divide it by 2 in order to have a common factor with this expression, and we will get that the area of triangle EBC equals to 2 times, here we will get 3 times 2 is 6 over 2 minus square root of 17 minus 3 here 2 over 2 is 1, so we will get that the area of the green right triangle, triangle EBC, equals to 2 will get cancelled. 2 over 2 is 1, so 2 will get cancelled. It equals to 6 minus square root of 17 minus 3. So we found out that the area of the right green triangle, triangle EBC, equals to 6 minus square root of 17 minus 3. So here we will open the brackets. Minus times minus is plus, so we'll get that the area of triangle EBC, the green right triangle, triangle EBC, equals to 6 minus square root of 17. 6 minus minus 3 is plus 3. So in total we found out that the area of triangle EBC, the right green triangle, triangle EBC, equals to 6 plus 3 is 9 minus square root of 17 units. So we found out that the area of the right green triangle, triangle EBC, this green right triangle, equals to 9 minus square root of 17 units, or in terms of numbers, it equals to 4.88 units. I will repeat again. The area of the green right triangle equals to either 9 minus square root of 17 units, or in terms of numbers, the area of this green right triangle equals to 4.88 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of this green triangle, and we have here square ABCD. The length of one side of square ABCD equals to 4 units. Inside this square we have a circle, and the radius of this circle equals to 1 unit. And we also know that one side of square ABCD equals to 4 units, and the radius of this circle equals to 1 unit, and we want to find out the area of the green triangle. So, first of all, I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. Okay, what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and tangent AB is tangent to this circle at point M. Point M is the point of tangency of tangent AB with this circle. So, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tangency. As you can see here, the radius OM is drawn to the point of tangency. Therefore, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be equal to 90 degrees. So whenever you have a radius, like in this drawing, that is drawn to the point of tangency, that is to say, this radius drawn to the point of tangency, that is point M, then the tangent AB will be perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So we actually implemented rule number 1 in our drawing. In our drawing, we have this radius is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency of tangent DA with this circle. Therefore, the tangent AD will be perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And we also know that all the angles inside the square are right angles, therefore this angle, it equals to 90 degrees because it is 1 out of 4 angles of the square ABCD. And we also have this radius that is drawn to the point of tangency, that is to say, it is drawn to point N, that is the point of tangency of tangent AB with this circle. Therefore, the tangent AB is perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So as you can see here, if we relate to quadrilateral, the small quadrilateral MOAN, it has 4 right angles, 1, 2, 3. Okay, and we have, it has 3 right angles, 1, 2, 3. And we have rule number 2. So quadrilateral MANO has 3 right angles. The sum of those 3 right angles is 270 degrees. And this angle is defined as angle X. So in total, the sum of the 4 angles inside the quadrilateral MANO equals to 270 degrees plus X. And according to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. So, and especially in quadrilateral MANO, the sum of its angles is equal to 360 degrees according to rule number 2. That is to say, 270 degrees plus x, that is the sum of the four angles of quadrilateral MANO, equals to 360 degrees, according to rule number 2. We will subtract 270 degrees from this equality, and we will get that angle x equals to 360 degrees minus 360 degrees minus 270 degrees equals to 90 degrees. So we found out that this angle is the right angle, that is to say it equals to 90 degrees. And as you can see here, quadrilateral MOAN has four right angles, 1, 2, 3, 4. And we have rule number 3 that states that any quadrilateral that has four right angles must be at least a rectangle, if not a square. So here, quadrilateral MOAN that has four right angles, it must be at least a rectangle, so we will relate to quadrilateral MOAN as a rectangle. Okay, we will relate to quadrilateral MOAN as a rectangle because it has four right angles. According to rule number 3, it must be at least a rectangle. And we also have rule number 4 that states that the opposite sides of a rectangle are equal to each other. The opposite sides of a rectangle are equal to each other. So we relate to quadrilateral MOAN as a rectangle. So in rectangle MOAN, the opposite sides are equal to each other. That is to say, MO equals to AN according to rule number 4. MO equals to AN according to rule number 4, that the opposite sides of a rectangle are equal to each other. But we know that MO equals to 1 unit. It is given us in the question. So MO equals to 1 unit. So from this equality we will get that AN also equals to 1 unit. Likewise, we also, according to rule number 4, MA also equals to ON. MA equals to ON according to rule number 4. But we know, we already found out that ON equals to 1 unit. ON equals to 1 unit. So from this equality we will get that AM, we will get that AM equals to 1. From this equality we will conclude that AM equals to 1. Okay? AM equals to 1. AM equals to 1. So we actually found out that all the sides of quadrilateral MOAN are equal to each other. They are all equal to 1 unit. Okay, so quadrilateral MOAN has 4 right angles and it also has 4 equal sides. They are all equal to 1 unit. And we also have rule number 5. According to rule number 5, any quadrilateral that has 4 right angles and 4 equal sides is a square. And quadrilateral MOAN, this quadrilateral has 4 right angles and 4 equal sides. Therefore, quadrilateral MOAN is a square according to rule number 5. So quadrilateral MOAN is a square according to rule number 5. Okay, according to rule number 5, quadrilateral MOAN, this quadrilateral is a square. And we also have rule number 6. According to rule number 6, the diagonals of a square bisects the angles of the square into 45 degrees angles. So, according to rule number 6, the square, the small square MOAN, its diagonal is OA, and this diagonal bisects its angles into 45 angles. This is to say this angle equals to 45 degrees, and this angle also equal to 45 degrees according to rule number 6. Likewise, if we relate to the big square ABCD, according to rule number 6, the diagonal CA of square ABCD bisects its angles. That is to say, this angle equals to 45 degrees and this angle equals to 45 degrees. And if we relate to angle CAB, it equals to 45 degrees. But if we relate to the small diagonal, then angle OAN also equals to 45 degrees according to rule number 6. But the real issue is that angle OAN is exactly the same angle as angle OAB. Why they are the same angles? Because point N is located on AB. Point N is located on AB. Therefore, it doesn't matter if it is angle OAN or angle OAB, they are exactly the same angles. Okay? We know that tangent AB is tangent to the circle at point N. It means that point N is located on the tangent AB. Therefore, that is to say, AN and B are located on the same straight line. So, therefore, it is the same thing to say angle OAN, it is exactly the same angle as angle OAB because of the fact that points AN and B are located on the same straight line. Okay, so instead of angle OAN, we can say angle OAB, and it will be exactly the same angle, that angle that is equals to 45 degrees. Okay? So, angle OAB, this angle OAB equals to 45 degrees, according to rule number 6. Angle CAB also equals to 45 degrees, according to rule number 6. So, actually, angle OAB equals to angle CAB. Okay, angle OAB equals to angle CAB. Okay, those two angles are equal to each other. We derive from the fact that those two angles are equal to each other, angle OAB equals to angle CAB, that the diagonal CA of square ABCD passes through point O. Okay, the diagonal CA of square ABCD passes through point O. Why diagonal CA passes through point O? Because of the fact that angle OAB equals to angle CAB. Okay? Therefore, the diagonal CA must pass through point O. Otherwise, if not, then angle CAB will never be equal to angle OAB. In order that angle CAB will be equal to angle OAB, the diagonal CA must pass through point O. Otherwise, angle CAB can never be equal to angle OAB. Okay, therefore, the diagonal CA must pass through point O in order that angle CAB will be equal to angle OAB. Okay? And we have also rule number 7. According to rule number 7, the length of the diagonal of a square is equal to square root of 2 multiplied by the length of the side of the square. So what is the meaning of rule number 7? The meaning of rule number 7 is that if you have this square ABCD, and we know that the length of the side AB that equals to side AD that equals to side DC and side BC, because it is a square, if the length of one side is equals to S units, then the length of its diagonals, it will be equal to S times square root of 2 units. Okay? So if the length of a square is S, if the length of one side of a square is S, then its diagonals, the length of its diagonals will be equal to S times square root of 2 units. That is the meaning of rule number 7. And we will actually implement rule number 7 in our drawing. Okay, because in our drawing we have the small square, MOAN. We know that the length of one side of square MOAN is 1 unit. Then, according to rule number 7, the length of its diagonal will be equal to square root of 2 times 1 unit. That is to say, the length of diagonal AO of square MOAN equals to square root of 2 units. So the length of diagonal AO of the small square equals to square root of 2 units. Likewise, if we relate to the big square ABCD, then we know that the length of one side of square ABCD equals to 4 units. Therefore, according to rule number 7, the length of its diagonal AC, will be equal to square root of 2 times 4 units. The length AC of diagonal AC will be equal to 4, that is the length of its side, times square root of 2 units. This is according to rule number 7. Okay? So we know that AC equals to 4 times square root of 2 units, and OA equals to the square root of 2 units. So what is the length of CO? So you can see from the drawing, CO equals to AC minus AO. Okay, as you can see here, CO equals to AC minus AO. CO, the length of diagonal AC is the diagonal of square ABCD is AC, and AC equals to 4 times square root of 2 units, and CO equals to CA minus AO. CO equals to CAC minus AO. So CO equals to AC, that is 4 times square root of 2 units, minus CO, that is square root of 2 units, that is to say 4 times square root of 2 units minus square root of 2 units equals to 3 times square root of 2 units. So we found out that CO equals to 3 times square root of 2 units. Okay, CO equals to 3 times square root of 2 units. And we already know that OK is the radius of this circle, that is to say it equals to 1 unit. So if we relate to this right triangle CKO, we can find out the value of CK because it is the only missing variable. Okay. So we relate to the right triangle COK. In the right triangle COK, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, CO square equals to OK square plus KC square. CO square equals to OK square plus KC square. But we have already found out that CO equals to 3 times square root of 2 units. Therefore, CO square will be equal to 3 times square root of 2 units squared. OK equals to 1, so OK square is 1 square is 1, and KC square is KC square, it is the missing variable. So 3 times square root of 2 square equals to 9 times 2, because square root of 2 square is 2. In total, square root of 3 times square root of 2 square, it is 9 times 2, and it equals to 1 plus KC square. So 9 times 2 is 18, so 18 equals to 1 plus KC square. We subtracted 1 from this equation number 1. 18 minus 1 is 17. So we got that 17 equals to KC square. Then we took a root out of this equation number 1, and we got that Kc equals to the square root of 17 units. So Kc, we found out that this line segment Kc equals to square root of 17 units, so side Kc of the right triangle is KCO equals to square root of 17 units. Okay, then I presented to you a new rule number 8. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 8? The meaning of rule number 8 is that if we have this circle and the external point P of this circle, and from the external point P we will draw two tangents to this circle. This is the first tangent. The point of tangency of the first tangent is point A, and then we have the second tangent. The point of tangency of the second tangent to this circle is at point B. Then the lengths of two tangents from a common external point to a circle are equal. So whenever you draw two tangents from a common external point, that is to say point P, to the circle, then the lengths of those two tangents will be equal to each other. That is to say, the length of the first tangent is PA, the length of the second tangent is PB. And according to rule number 8, the length of those two tangents that are drawn from an external point of the circle to the circle, the lengths are equal to each other. That is to say, PA equals to PB. That is the meaning of rule number 8, and we can implement rule number 8 in our drawing, because in our drawing we have the external point E, and from the external point E we have two tangents to this circle. The first tangent is tangent EK, and the second tangent is tangent EN, and according to rule number 8, the length of those two tangents are equal to each other. That is to say, EK equals to EN. According to rule number 8, EK equals to EN. We defined EK as x, therefore EK equals to EN equals to x. So we defined EN as x, then EK will be also equal to x because they are equal to each other. And then we actually implemented the Pythagoras theorem on the green right triangle. Why the green triangle is a right triangle? Because this angle is a right angle. Because all the angles inside the square are right angles. So this angle is 1 out of 4 angles of square ABCD, therefore it is a right angle. Therefore, triangle CEB is a right angle. So we can implement the Pythagoras theorem on the right green triangle, triangle CEB. On the right green triangle, triangle CEB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is CE. The hypotenuse is CE, so the square of the hypotenuse is CE squared. It equals to the sum of the squares of the perpendiculars. That is to say, it equals to EB squared plus CB squared. Again, CE square equals to EB square plus BC square. We have already found out that CE equals to square root of 17 plus x. Therefore, CE square will be equal to square root of 17 plus x squared. And EB equals to 3 minus x, therefore EB square will be equal to 3 minus x squared. BC equals to 4 units, so BC square will be equal to 4 square. 4 square is 16. So BC square equals to 16. Here we open the brackets of this equation, equation number 2, and we got that square root of 17 plus x squared equals to 17 plus x squared plus 2 times square root of 17x, and it equals to 3 minus x squared. 3 minus x squared equals to 9 plus x squared minus 6x, and we have here 16, so here we will also have 16. Here we have x squared on both sides of equation number 2, so x squared will get cancelled, and what is left after we cancel x squared? What is left is 17 plus 2 times square root 17 plus 2 times of square root of 17x, and 9 plus 16 is 25. Here is minus x, so minus x is left is minus 6x. Minus 6x equals to is left as minus 6x. We copied it from here to here. So here we subtracted from this equation number 2, 17. 17 minus 17 is 0, so what is left in this side of equation number 2 is 2 times square root of 17x, and 25 minus 17 is 8. So here we got 8, and what is left here is minus x, so we copy it here, minus 6x. In total we got that according to equation number 2, 2 times square root of 17x equals to 8 minus 6x. Here we divided equation number 2 by 2, and we got 2 times square root of 17x over 2 is square root of 17 times x. 8 times 8 over 2 is 4, and minus 6x over 2 is minus 3x. So in total we got that the square root of 17x equals to 4 minus 3x. So here we added 3x to this equation number 2, and we got that square root of 17x plus 3x equals to 4. Here we took a common factor x from these expressions, and we got here, so here x is a common factor, so what is left from the square root of 17 times x after we took x as a common factor? What is left? It is actually minus, what is left? It is actually square root of 17, and what is left from 3x after we took x as a common factor? What is left? It is actually 3. So in total we got that x times square root of 17 plus 3 equals to 4. Here we divided equation number 2 by square root of 17 plus 3, and we got that x equals to 4 over square root of 17 plus 3. Okay, here we don't like that we have roots and fractions in the denominator. Therefore, we actually, in order to eliminate the roots and the fractions in the denominator, we multiplied this expression by square root of 17 minus 3, and then we divide it by the same expression in order to eliminate the root and the fractions in the denominator. So we got that x equals to 4 over square root of 17 plus 3. We multiply it by square root of 17 minus 3, and then we divide it by the same expression, so it is allowable because we changed nothing. So here we got this expression, and we found the value of this expression according to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. So according to this algebraic identity, square root of 17 plus 3 times square root of 17 minus 3 will be equal to a squared is 17 and minus b squared is minus 9. So in total we got that this biggest expression equals to 17 minus 9, and in the numerator we have 4 times square root of 17 minus 3. Okay, so in total we got that x equals to 4 times square root of 17 minus 3 over 17 minus 9, and we know that 17 minus 9 is 8, so we got that x equals to 4 times square root of 17 minus 3 over 8. Here we divided this equation number 4, equation number 2 by 4. 4 over 4 is 1, so 4 will get cancelled. 8 over 4 is 2, so in total we got that x equals to square root of 17 minus 3 over 2. So we found out the value of x. This is the missing variable. And we know that the general formula for the area of any triangle is the base of the triangle times the height of the to the base over 2. So we use this formula in order to calculate the area of the right green triangle, triangle EBC. The base of the green right triangle, triangle EBC is EB. The height is BC. So in total we got that the base is EB, the height is BC over 2. This is the area of the green right triangle, triangle EBC. What is the value of EB? The value of EB is 3 minus x, and the value of BC is 4. Okay, the value of EB is 3 minus x, and the value of BC is 4. So we got that the area of triangle EBC equals to 3 minus x times 4 over 2. 4 over 2 is 2, so in total we got that the area of the green right triangle, triangle EBC equals to 2 times 3 minus x. And we actually placed the value of x inside x, and the value of x is actually square root of 17 minus 3 over 2. So we placed the value of x inside x, and we got this expression that the area of the right green triangle, triangle EBC equals to 2 times 3. This expression is x. And here we multiplied 3 by 2, and then we divided it by 2 in order to have a common factor with this expression. So in total we got that the area of the green right triangle EBC equals to 2 times 6 minus square root of 17 minus 3 over 2. 2 over 2 is 1, so 2 will get cancelled, and in total we left only with 6 minus square root of 17 minus 3. Okay, in total we left with 6 minus square root of 17 minus 3. So we open the brackets inside here in this expression. So we get that the area of the green right triangle EBC equals to 6 minus square root of 17, and here minus times minus is plus. So we got that it equals to 6 minus square root of 17 plus 3, because minus times minus is plus. So the area of the green right triangle, triangle EBC equals to 6 plus 3. 6 plus 3 is 9. 9 minus square root of 17. So the area of the green right triangle, triangle EBC equals to 9 minus square root of 17 square units, or in terms of numbers, the area of the green right triangle, triangle EBC equals to 4.88 square units. I will repeat again. The area of this green right triangle, triangle EBC equals to either to 9 minus square root of 17 square units, or in terms of numbers, the area of this green right triangle EBC equals to 4.88 square units. Okay, thank you very much.